Earlier today, I started talking about a pulley and you attach a weight to it. So let's go back to that story. We got a pulley here, and you have a weight attached to it. Mass M. You take a half a kilogram, maybe half a kilogram, you attach to it. Initially, this is not moving. So the angular speed is 0, and the linear speed is 0. Linear speed is how fast this weight is moving down, and angular speed, how fast the pulley is spinning. Well, the way I drew that, which way the pulley is going to move? Clockwise, right? That means my angular speed will be negative, just like theta. If you go clockwise, that's negative. Counterclockwise, that's positive. So what's going to happen now, that this weight is going to go down, and this is going to be spinning in this direction. So W in this case will be, let me give you some number here, negative 8.4 rad per second. Again, the reason it's negative, it is going which way? Clockwise, spinning clockwise. We know the angular acceleration too, angular acceleration is negative 2.8. Angular acceleration alpha, not A, looks like A there. What is the angular velocity of the pulley at 1.5 second? What's the angular velocity? Time equals 1.5 second. So again, somebody was holding that weight, that mass there in their hand, so nothing was moving. You let go. Things start to spin, the mass goes down. What I'm looking for is W. So this is where I know. I know the initial speed of this is 8.4. That's the initial one. So I know the initial angular speed is negative 8.4 rad per second. Negative again is going clockwise. I know alpha, the acceleration, is negative 2.8 rad per second squared. I know the time equals 1.5 second. And I'm looking for the final angular speed. Is there an equation that has all these pieces put together? If you look at the equation we mentioned, is there one that has all the pieces? How about the first one, which says W equals W0 plus alpha t? Do we know what W0 is? Negative 8.4 plus alpha, which is negative 2.8, the time, which is 1.5. And I came up with negative 12.15 rad per second. Again, what does the negative tells me? The negative sign tells me what's going clockwise. That's what the negative tells me. Not slowing down. It's not actually going to pick up speed. Let me try another example like these. I'll use baseball here. I'll use the Red Sox. They stink. Their pitching stinks. Here we go. Clay Buchholz, yesterday. I know, nobody wants to hear his name. Throws a curveball. Now the curveball, what they do, they take their finger, when they release the ball, they make the ball spin. They make it spin, and that's why the ball dips down. So the initial angular speed, W0, for that ball is 36 rad per second. He throws a curveball. It doesn't really take that long for the ball to go from the pitcher's hand to the catcher's hand. Usually about a half a second. So let's say for this it took 0.6 seconds the time. Curveball not as fast as fastball. Fastball about half a second. That's why the hitter has half a second to make up their mind. Swing or not swing on that ball. When we watch on TV, like, what'd you swing at that for? Blink your eye and the ball is there. So you got to decide quickly, yes or no. 0.6 second. So the catcher grabs it at 0.6 second after the pitcher throws the ball to him. But when the ball arrives to the catcher, because the way the wind is hitting it there, the final angular speed is different. It's slowed down. It might be 34, let's say 34 even, rad per second. And we have a few questions here. First question, A, find the angular acceleration alpha. And B, how many revolutions did the ball spin? Number of revolution by the time the ball went from the pitcher hand to the catcher. I have two questions. The number of revolutions. Finding alpha is not bad, straightforward. Same as the example before, the same equation. I can use W equals W0 plus alpha t. W is 34, W0 36, alpha I'm looking for it, and t is 0.6. Two divided by 0.6, 1 point something. Oh, 0.3, right? 3.3. So the acceleration is 3.3 rad per second squared. That's part A. Then what's part B? How many revolution? We need to know what theta is. How many radian did it make it? And if I know how many radian, I can tell you how many revolution. So in part B now, I need to find theta. So let's take a look which equation. I'm looking for x basically. I can use the last equation, which says w squared equals w0 squared plus 2 alpha change in theta. W is what? 34 squared equals 36 squared plus 2 times alpha, I just did alpha, which is negative 3.33, times delta theta. 34 squared. Now I'll bring the 36 already to one side. I'll do the whole thing. Minus 36 squared. Negative 140. I'm taking a step out. Negative 6.66 delta theta. Can we get delta theta? And I get 21 radian. Notice it's positive here, which means counterclock. The question is not how many radian, how many revolution. To convert from radian to revolution, we said what? 21.0 radian over 1. One rev is 2 pi. So you divide that by 2 pi. Okay, I screwed up. 21 divided by 2 divided by pi, 3.34. So the ball spun actually around 3 1/3 times by the time it went from the pitcher hand to the catcher's hand. So next time you see a pitcher throws a curveball, you know what happened actually. You put that little spin on it with their finger. When they throw it, they hold it like this and they spin the ball. And that's what makes it start spinning and dips down there. Let's try another one. Like these. Big Money. What's that show? Wheel of Fortune again? Come on, Big Money. You spin a wheel there. So they call you down. Come on down. Zi Haddad, come on down. You go down, you spin that wheel. And you wait for it to land and see where it's going to land. 1,000, 2,000, bankruptcy, whatever, trip to Hawaii, whatever the case is. I spun the wheel with initial angular speed, W, equals 3.4 rad per second, positive. That means counterclockwise. That's what the positive tell you. Counterclockwise. Then it's going to spin around for a while. And let's say it spun actually the change of theta. Let's say I didn't spin it that hard, 1.5 revolution. Then usually it comes to a stop. You wait for it till it stops, so your final angular speed is 0. Find the angular acceleration. We'll ask for two things. Question number 1, find the angular acceleration, which is alpha. Question number 2, let's find the time. How long it took for it to come to a complete stop. Okay, let's see what's happening. The first one. So we have W0, which is 0. We have W, which is 3.4. Backward. Didn't we spin this one, right? Isn't that we spun the wheel of fortune here? Those are backward. I spun it initially with that number, and final velocity stops. We know delta theta. Now I'm looking for the time. And I'm looking for alpha. You decide which one you want to do first. Well, it looks like I didn't give you enough information. That's why I asked you for 2 questions, actually. Because any way we look at it, if I use that equation, that's W equals W0 plus alpha t. I can't use it. I don't know alpha, and I don't know what t is. Maybe I can get t from here. I just realized that we can get t from here. Can you see this equation? Equation number 3. Theta equals theta 0 plus 1/2 W0 plus W times t. I can get t from that equation. Oh, wait a minute. Yep. We know it turned what? 1.5? So that's revolution. Rev. I need to convert that. One revolution is 2 pi radian. So before I do anything, I should convert that one to radian. And it's 9.42. So let's plug them in. 9.42 equals theta 0, which is 0. I'm assuming where we start from is 0, and this how far you went. Plus 1/2 W0, which is 0. Well, it doesn't matter which one. 3.4 plus 0, or 0 plus 3.4, but if you want to put each one under their value, write 3.4 plus 0 times t, which is unknown. Can you solve for t? Yeah. 9.42 equals what? 1.7 t. 5.54. So it's going to take 5.54 seconds for the wheel to come to a complete stop. Next, I need to find alpha. Well, once I know what the time is, I can use equation number 1. W equals W0 plus alpha t. I know what t is. I know what W is. 0, 3.4 alpha times t. T is what? 5.54 seconds. And I got negative 0.613 radian per second squared. I was watching yesterday, Deadliest Catch. I love that show. But this is what I noticed on it, and I said, oh, that'll be a good example to use. You get when they go to pull the traps out of the water there, you get the wheel spinning. So the wheel is spinning in this direction. You see the guy takes the hook, throws it out there, grabs the rope, pulls it in, throws it over the wheel. So what's going to happen, that thing, the tank way in the water down there, full of all these little crabs there in them. It's a good day today, lots of them. It's loaded with crabs there. So here's what I noticed about I'll give you some initial speed, how fast this one was moving. Let's assume that initial velocity on that one, the angular speed, was 5.40 rad per second. 40, not 04, 40. Now, once you attach that weight to it, the trap there, what's going to happen to that speed? It should slow down. So if you take a wheel, spin it really fast, and you take a string, attach a rock to the bottom and throw it on top of it, it's going to start to wrap, or the string will wrap around this, and this will slow down till eventually comes to what? To a stop. And if you wait long enough, one stops, then start to go backwards, start to spin backwards, start to pick up speed and go down there. So final velocity or final speed when it comes to a stop, that's 0. The acceleration, the angular acceleration alpha is negative 2.10 rad per second squared. Again, the first question, A, let's find the time, how long it takes the pulley to come to a complete stop. And 2, find theta. How many radian did it travel? And if I know what R is, I can tell you how fast this one is moving. We'll get to that in the next segment. So now we know I got to find an equation that will tie them together. And the first one, to find T, it's really the first equation. If I use that, W is 0. W0 is 5.40. Alpha is negative 2.10 times T. 2.10 T equals 5.40. Time will never be negative. That's one way to know if you put the right values there. If you put T0 versus T final, 2.57 seconds. That's the time. And the next question, can we find theta? I can use the last equation. I can use that one. W is what? 0. Square it. W0 is 5.40 squared plus 2 times alpha. Alpha is negative 2.10 times delta theta. .40 squared, 29.16 minus 4.2 delta theta equals to 0. Move it to this side. What's the change in theta? .94 radian. Again, if you want that in revs, you divide it by 2 pi. That will tell you how many times that wheel went around before it came to complete stop. The one at Deadliest Catch, they spin really high speed there, and they keep it spinning. They have a motor attached to it. In this example, this just like you went with your hand like a bicycle wheel, just kept hitting it till it picked up some speed. Then you tied the rope to it and let it go. No more additional push. So eventually it's going to slow down. And slow down, slow down, slow down till it stops. Again, if you want to find that in terms of revs there, you go 6.94 radian. One rev is 2 pi. If you divide it by 2 pi, that will tell you how many revolutions. 1.1. Maybe I'll separate the videos so